Vector database and word embeddings. Have you ever wondered how our computers can understand and interpret the complex nuances of human language? From social media posts to customer reviews, the sheer volume of textual data we generate every day is staggering. As natural language processing has exploded its popularity, so it requires innovative techniques to process and make sense of this vast trove of information. So this vector database and word embeddings are two game-changing technologies that allows us to turn that text into insights, which unlocks the power of NLP and revolutionizing the way we interact with computer. So today we'll take on a journey through the world of vector databases and word embeddings, delving into the fascinating concepts that enables computers to comprehend and process language in a way that was once thought impossible. So let's get started with word embeddings. Now, these word embeddings are a way to represent words in a way that captures their meaning and relations with other words in a language. They're used in natural language processing tasks such as text classification, machine translation, and question answer. Imagine that you have a large collection of text documents and you want to analyze them to understand the meaning of different words and their relations with each other. So one way to do this is to represent each word with a numerical vector where each element of the vector corresponds to a particular aspect of that word's meaning. For example, imagine you have a text document about fruits and you want to represent the word apple as a numerical vector. So this vector might include elements such as sweetness, color, shape, and origin with corresponding numerical values that capture the properties of apples. So these word embeddings are similar to this idea. But instead of manually selecting these elements of the vector, they use machine learning algorithms to learn the most informative features of that words automatically. And then these resulting vectors capture the meaning of words in a high dimensional space where words are semantically similar, are located close to each other. So here are some examples to illustrate how word embeddings work. First is the synonymy. That is, the words that are similar in meaning, such as happy and joyful, will be located close to each other in the word embedding space. Then antonymy means the words which are opposite in meaning, such as hot and cold, will be located far apart from each other. Then semantic analogies. The word embeddings capture the relations between the words in a way that allows you to perform analogies. For example, if you have a word embedding for king, man, and woman, you can use those embeddings to find the word that is queen to the woman, which is king, right? Fourth is contextual meaning. So the word embeddings capture the meaning of words in context. For example, the word bank might have different meanings depending on the context, such as financial institution, or it can be a river or a side of a river. So this word embeddings can capture the different meanings of bank depending on the context in which they appear. And there are several types of word embeddings, each with its own strength and applications. So let's discuss some of the commonly types of word embeddings. First is the continuous bag of words. So this continuous bag of words is an early type of word embedding that predicts a target word based on its surrounding context words. So in this, a neural network is trained to predict a target word given its context word or to predict a context word given a target word. So the word embeddings are learned through the training process. For example, given the sentence, the quick brown fox jumps over the lazy dog. So this continuous bag of words will learn embeddings for words like quick, brown, jumps, and lazy that capture their relations with other words. Then comes skipgram. So this skipgram is similar to this context bag of words, but it predicts the context word given a target word. This means instead of predicting a target word from its context word, the model now predicts the context word from the given target word. So for example, if you are given a sentence, the quick brown fox jumps over the lazy dog. So the skipgram model would learn embeddings for words like quick, brown, jumps, and lazy that capture their relations with other words. Then comes word2vec. Well, it's a popular technique that implements both this context bag of words and skipgram models, and it uses an efficient training algorithms and provides pre-trained word embeddings for various languages. For example, this word2vec library provides pre-trained word embeddings for English, Spanish, Chinese and many other languages, and these embeddings can be used for tasks such as sentiment analysis, machine translation and text generation. Then comes the globe or the global vectors. Now it learns word representation by factorizing a co-occurrence matrix. And this co-occurrence matrix is built from a corpus of text data, and the embeddings are learned by solving a set of linear equations. For example, Globe provides pre-trained word embeddings for English which can be used for a variety of MLP tasks. Then comes fast text. Well, this is an extension of word2vec that is designed to handle out of vocabulary words and subword information. And it uses n-grams to represent words which help to capture morphological and semantic relations between words. For example, fast text can be used to learn word embeddings for languages with a large vocabulary, such as Chinese, where a significant portion of text may consist out of vocabulary words. So in summary, there are several types of word embeddings, each with its own strength and applications, and these embeddings allow model to understand the meaning and relations between the words in a language. So let's explore vector database now. Now this vector database, it's a type of database that stores data as vectors, which are mathematical objects represented as array of numbers. And each vector is a vector database which represents an object or a piece of information about the object, such as document, an image or product. In a vector database, the vectors are typically used to represent the semantic meanings of objects rather than their raw data. And this is similar to the way that word embeddings represent words as vectors in natural language processing. For example, imagine you have a database of product description for an e-commerce website. So instead of storing the product description as a plain text, you could represent them as vectors in vector database, where each word would capture the semantic meaning of that product description, including its overall sentiments, the product features, and other relevant information. So let's take some examples how this vector database could be used. First is the document retrieval. So this vector database can be used to search and retrieve documents based on their semantic meanings. For example, a search engine could be used as a vector database to find documents that are similar in meaning to their user query. Then comes image recognition. So this vector database can be used to store and retrieve images based on their semantic content. For example, an image recognition system could use a vector database to find images that are similar to that query image. Then comes recommender system. So here this vector database can be used to represent user preferences and product features in a way that allows the recommender system to make personalized recommendations. And finally, it's a natural language processing. So this vector database can be used to represent words, sentences and documents in a way that captures their semantic meaning, which is useful for the tasks such as sentiment analysis, machine translation and text generation. So this vector database works by representing data as vectors, which are mathematical representation of information. And these vectors can be used to perform various operations such as similarity calculation, classification and clustering. So let's take an example to understand how a vector database works. So imagine you have a collection of customer reviews about a product. Now each review will be a string of text that describes a person's opinion about the product. To process these reviews and extract that meaningful insight, you can use the vector database, which involves the following step. First step is tokenization. So in this tokenization, these reviews is to break them down into individual words or tokens. So for this you use a tokenizer which divide each reviews in a list of words. Like for example, a review might be this product is really great, I highly recommend this. The tokenizer would convert this review into a list of words, like it has simply broken the reviews in a list of words. This product is like this. Then comes vector representation. So each word in this collection of reviews can be represented as a vector using a word embedding model. Now this word embedding model, it captures the meaning of words and can be used to compare the similarities. For example, using a word embedding, the word great might be represented as a vector like this, right? Third comes the similarity calculation. So once the reviews are calculated as vector, you can calculate that similarity between any two reviews, which is done by cosine similarity between the vectors. For example, here the cosine similarity between the vectors for the product is great and I love this product would be high value, means these reviews are similar. Then comes classification. So you can use the vector representation of reviews to classify them into different categories. For example, you might want to classify reviews as positive or negative. So here the example is, suppose you can train a classifier on the vector representation of reviews and their corresponding labels as positive or negative. So the classifier would learn to distinguish between this positive and negative reviews based on the similarity of their review vectors. And finally, it's clustering. So you can use clustering algorithms on this vector representation. For example, here we have shown that you can use a clustering algorithm on vector representation to group them into categories such as positive or negative aspects. So in summary, this vector database is a way to store and retrieve the data, right? And in a way that it captures the semantic meaning. So by using vectors to represent data, vector database allows for more sophisticated research, recommendation and analysis tasks than the traditional database. Thank you.